California's iconic San Andreas Fault, a symbol of both awe and fear, now stands on the brink of unleashing what could be the biggest tsunami in history. But how close are we really to facing this colossal disaster? Is the land we walk on as stable as we believe, or is a catastrophic event lurking beneath our feet? The San Andreas crack threatens more than just the landscape. It's a ticking time bomb for millions. Join us as we explore the startling signs and the chilling possibilities of what lies ahead. The San Andreas Fault, a massive fracture in the Earth's crust, plays a pivotal role in shaping California's landscape. Stretching over 800 miles, this fault line extends from the Salton Sea in the south to the north through California's coastal and inland regions. It's not just a geographical feature, but a significant geological force known for its ability to cut California in half literally. The San Andreas Fault is where two major tectonic plates, the Pacific and the North American, meet and grind against each other. This constant movement and pressure make the fault line a hotbed for seismic activity, with the potential to cause devastating earthquakes. The San Andreas Fault has a notorious history of seismic events. Two of the most significant earthquakes in U.S. history have occurred along this fault. The 1906 San Francisco earthquake, a catastrophic event, still haunts the American psyche more than a century later. With a magnitude of approximately 7.9, it caused widespread destruction and loss of life, reshaping the city of San Francisco. Fast forward to 1989, and the Loma Prieta earthquake struck with a magnitude of 6.9, causing significant damage and fatalities, particularly in the San Francisco Bay Area. These historical earthquakes are stark reminders of the San Andreas Fault's immense power and the potential danger it poses to the populated areas along its path. In addition to these major events, the fault has experienced numerous smaller tremors and quakes over the years, continually reminding Californians of its active presence. The 1906 earthquake was particularly notable for demonstrating the fault's long reach, affecting areas hundreds of miles away. It also led to significant advancements in earthquake science, as it was one of the first major quakes studied in detail. The Loma Prieta earthquake, occurring during the World Series, brought worldwide attention to the risks posed by the San Andreas Fault. Also, it led to improvements in emergency response and building standards across California. The fault's activity has shaped the physical landscape and policies and practices around urban development and disaster readiness. According to recent reports, another natural disaster is likely on the horizon, with the San Andreas crack expected to cause the biggest tsunami in recent history. The San Andreas Fault isn't just something scientists talk about. It's become a big deal in movies and on TV, where it's often shown as a sign that something terrifying is about to happen. Think of movies like San Andreas, where the fault line is shown as this huge thing that could tear California in two. Sure, these movies tend to make it look scarier than it really is, but because of them, many people now see the San Andreas Fault as dangerous and unpredictable. Even though these movies go over the top, they do remind us that the fault line is a real threat. This means people in California and all Americans should know about it and be ready for what could happen. Movies and TV shows about the San Andreas Fault have really made people pay more attention to earthquakes. This is good because more folks are learning about earthquakes and how to prepare for them. But on the other side, these shows can get things wrong and make people believe myths about earthquakes and the science behind them. The big exciting scenes in these movies start many talks about the best ways to get ready and deal with big earthquakes. Schools and communities are using these movies as a way to teach people about what to do in real earthquakes, like the right safety steps and emergency plans. Also, because of how popular these movies are, even the people who make big decisions, like those in charge of cities and emergency services, are thinking more about planning and managing disasters. So, even though these movies aren't always right about the science, they've really helped get people talking and doing things about staying safe in earthquakes. In a way, how the San Andreas Fault is shown in movies and TV has really changed how people think and act regarding earthquake dangers. The San Andreas Fault is a striking example of the dynamic nature of Earth's crust, where the immense forces of tectonic plates are at play. It's a boundary between the Pacific Plate, which moves northwest, and the North American Plate, creating a transform fault where these plates slide past each other. This movement isn't smooth, but occurs in fits and starts, leading to the buildup and sudden release of energy, causing earthquakes. The fault's mechanics are a classic representation of the strike-slip fault, where the motion is primarily horizontal. Understanding this helps explain why the San Andreas Fault is so prone to seismic activity, as the continual geological movement near its base is the primary cause of earthquakes in this region. The rate of movement along the fault varies but averages about an inch to an inch and a half per year. This gradual motion accumulates significant energy over time, which eventually gets released as earthquakes. The areas along the fault where movement is locked due to friction between the tectonic plates are typically where stress accumulates the most and where powerful earthquakes are more likely to originate. Interestingly, the San Andreas Fault's impact is not just confined to California. It influences seismic activity across the western United States. Scientists use advanced monitoring technologies, including GPS and seismometers, to track the fault's movement and predict potential seismic events. This ongoing research is crucial in understanding the fault's behavior and preparing for future earthquakes. However, recent information about the fault presents new problems for the future. Recent studies and research have provided new insights into the San Andreas Fault. Experts have found out that for nearly 100 years, there's been more and more pressure building up along the fault line. This means there's a big chance we could see a major earthquake soon. Thomas Jordan, director of the Southern California Earthquake Center, warns that the fault appears to be in a critical state. Research indicates that the Pacific Plate is moving northwest relative to the North American Plate, with an expected movement of about 16 feet every 100 years. Additionally, segments of the fault, like the one southeast in the Cajun Pass, have not shifted significantly since an earthquake in 1812, hinting at a potential for a future seismic event. Several myths surround the San Andreas Fault and earthquakes in general, which need to be addressed. Firstly, the idea of California sinking or breaking off into the ocean due to an earthquake along the San Andreas Fault is a misconception. The nature of the fault's movement does not support such an event. Another common myth is the prediction of earthquakes. Despite advancements in seismology, predicting an earthquake's exact time, place, and magnitude remains beyond our current scientific capability. This highlights the importance of ongoing research and the need for preparedness rather than relying on predictions. The San Andreas Fault is currently in a state of heightened observation due to its potential for seismic activity. Recent studies and seismic measurements indicate that the fault is under considerable stress. This stress accumulation is a concern, as it could lead to a sudden release of energy, resulting in an earthquake. The Southern California Earthquake Center has identified critical segments of the fault, particularly in Southern California, that appear locked, loaded, and ready to go. These segments have not experienced significant movement in recent years, adding to the concern of a major seismic event. The probability of a major earthquake occurring along the San Andreas Fault is a subject of serious concern among seismologists. The fault has been relatively quiet for a significant period, which suggests an increasing likelihood of a major seismic event in geological terms. Historical patterns and current scientific understanding indicate that the San Andreas Fault is overdue for a major earthquake. Experts like Thomas Jordan have warned that the fault is in a critical state with a possibility of a major earthquake of magnitude 8 or higher. The last major earthquake in this region, the Fort Tejon earthquake of 1857, was a magnitude 7.9 event, and current conditions suggest that a future earthquake could be of similar or greater magnitude. People are on the lookout for a big earthquake along the San Andreas Fault, and there's a good reason for that. Experts have figured out that big earthquakes happen there about every 150 years. The southern part of the fault hasn't had a major shake since the late 1600s. Plus, there's a lot of pressure building up along the fault line, making experts think a big earthquake could happen soon. This is especially worrying because of the dense population living near the fault, in crowded cities like Los Angeles and San Francisco. A big earthquake there could wreak havoc on the communities there. That's why seismologists are keeping a super close eye on the fault and using high-tech technology to try to detect any early signs of an earthquake happening. While the San Andreas Fault is primarily known for its earthquake potential, there is also a concern about the risk of a tsunami triggered by seismic activity along the fault. The fault's extensive reach through coastal and inland areas of California poses a unique challenge in assessing tsunami risks. Although a tsunami directly caused by the San Andreas Fault is less likely due to its nature as a strike-slip fault where horizontal movement dominates, secondary effects of a major earthquake, such as underwater landslides or the displacement of ocean waters, could potentially trigger a tsunami. The impact of such an event would be most pronounced in coastal regions, necessitating a thorough assessment of oceanic and coastal vulnerabilities. In response to the looming threat of a major earthquake along the San Andreas Fault, California, its local communities have been actively preparing for such an event. The state government, recognizing the severity of the potential impact, has been collaborating with seismic experts and local authorities to develop and implement comprehensive earthquake preparedness plans. These include emergency response protocols, resource allocation strategies, and community training programs. Local communities, particularly in vulnerable areas along the fault line, have been encouraged to participate in earthquake drills and to develop community-specific response plans. This collective effort aims to minimize the impact of a potential earthquake and ensure a swift, coordinated response. One of the key areas of focus in earthquake preparedness is enhancing infrastructure resilience. California has been proactive in retrofitting and strengthening its infrastructure, including buildings, bridges, and utilities, to withstand seismic forces. Building codes have been updated to require earthquake-resistant designs, especially for new constructions in high-risk areas. Older buildings, particularly in densely populated urban areas, are being retrofitted to improve their structural integrity. This effort extends to critical infrastructure like water supply systems, power grids, and communication networks, ensuring they remain operational or are quickly restored after an earthquake. Los Angeles, for instance, has been commended for its initiative in retrofitting apartments and concrete structures, setting an example for other cities to follow. The state has also invested in early warning systems that can provide crucial seconds or even minutes of notice before the shaking from an earthquake reaches populated areas. This technology has the potential to save lives by giving residents time to take cover and halting trains and other public transportation to prevent accidents. Public awareness and education are vital components of earthquake preparedness. The state has initiated public safety campaigns to educate residents about the risks of earthquakes and how to prepare for them. These campaigns provide practical information on creating emergency kits, developing family evacuation plans, and identifying safe spaces in homes and workplaces. Schools and public institutions participate in regular earthquake drills, reinforcing the importance of being prepared. Additionally, various communication channels encourage Californians to stay informed about the latest seismic research and advisories. This widespread public awareness effort aims to empower individuals with the knowledge and tools they need to protect themselves and their families in the event of an earthquake. The potential environmental impact of a massive earthquake and subsequent tsunami along the San Andreas Fault is a concern that extends beyond human structures. Such a seismic event could drastically alter landscapes, disrupt ecosystems, and harm wildlife. In the event of a large-scale earthquake, we could expect landslides, habitat destruction, and changes in water courses. A tsunami would worsen these effects, leading to coastal erosion, saltwater intrusion into freshwater systems, and destruction of marine habitats. These disturbances would affect the flora, fauna, and broader ecological balance, potentially leading to long-term environmental consequences. Climate change introduces an additional layer of complexity to the seismic risks in the San Andreas region. Rising sea levels and changing oceanic conditions could alter the impact patterns of a potential tsunami, increasing the risk of inundation in coastal areas. Warmer ocean temperatures might also influence seismic activity, although the extent of this impact is still a subject of ongoing research. As climate change progresses, it is crucial to consider these factors in seismic risk assessments and preparedness strategies for the region. This evolving dynamic underscores the need for adaptive and forward-thinking approaches to understanding and mitigating the risks associated with the San Andreas Fault. The effects of climate change on weather patterns, such as increased rainfall and flooding, can have indirect consequences on the fault's stability. Heavy rainfall can lead to soil erosion and landslides, potentially triggering minor seismic events or putting additional stress on the fault. The alteration in groundwater levels due to changing precipitation patterns may also affect the underground pressures along the fault lines. Furthermore, as coastal ecosystems like mangroves and wetlands, which act as natural barriers against tsunamis, are threatened by climate change, the vulnerability of coastal regions to tsunami impacts may increase. The focus on environmental recovery would be paramount after a major seismic event along the San Andreas Fault. The process of ecological restoration could take years or even decades, depending on the scale of the damage. Recovery efforts would likely involve reforestation, rehabilitating damaged waterways, and restoring wildlife habitats. Additionally, efforts would be made to mitigate soil erosion and manage the altered landscapes. The recovery process would aim to restore the damaged environment and enhance resilience against future seismic events. This long-term perspective is crucial for preserving California's natural beauty and ecological diversity, ensuring that the environment can thrive and support future generations. However, recent advancements in underwater research have opened new avenues for studying the San Andreas Fault, particularly its submerged sections. Innovative techniques like deep-sea drilling, remote-operated vehicles, and advanced seismic imaging are being used to explore the underwater portions of the fault. These methods allow scientists to collect data from the ocean floor, offering a unique perspective on the fault structure and activity. By studying these submerged sections, researchers can gain insights into the fault's behavior that aren't possible from land-based observations alone. This underwater exploration is crucial, as it provides a more comprehensive understanding of the fault's entire length, including its less accessible segments. The underwater studies of the San Andreas Fault have led to some exciting discoveries. Researchers have identified unique geological formations and previously unknown fault lines on the ocean floor. These findings include variations in the fault structure and evidence of past seismic activity that wasn't apparent from terrestrial observations. For instance, scientists have observed areas where the fault's movement differs significantly from that seen on land, providing new insights into its mechanics. These discoveries enhance our understanding of the San Andreas Fault and contribute to the broader field of seismology and tectonics. Underwater research has revealed how deep-sea sediments can record the history of earthquakes, offering a new method to study the frequency and magnitude of past seismic events. This research has implications for understanding the fault's long-term behavior and improving earthquake prediction models' accuracy. The exploration of deep underwater canyons near the fault has also provided clues about how seismic activity can trigger undersea landslides, which could potentially lead to tsunamis. The data gathered from these underwater explorations are also helping to refine our understanding of the interaction between tectonic plates, particularly in subduction zones where one plate slides beneath another. This is especially relevant for the areas where the San Andreas Fault interacts with other fault systems on land and underwater. This research is revolutionizing our understanding of the tsunami risks associated with the San Andreas Fault. By studying the fault's underwater sections, scientists can better predict how seismic activity along the fault could trigger underwater landslides or other events that might lead to a tsunami. This research is particularly important for coastal communities along the California coastline, where the threat of a tsunami triggered by an earthquake on the San Andreas Fault is a significant concern. The data gathered from these underwater studies are being used to develop more accurate models for tsunami generation and propagation, enabling better preparedness and response strategies for potential tsunami threats. This research enhances our understanding of the fault's behavior and structure, and also plays a critical role in improving tsunami risk assessments and preparedness efforts. As these underwater exploration techniques continue to advance, they will undoubtedly provide even deeper insights into one of the world's most famous and studied fault lines. However, the imminent catastrophe scientists predicted on the San Andreas crack remains a very real possibility for the near future, and it remains to be seen if we are prepared for it. Thanks for exploring with us on Beyond Discovery. If you enjoyed these revelations, click now on the next video that pops up on your screen. It's